Good morning, welcome to WASSCE Academy's online tutorial. Thanks for watching our YouTube tutorial online. Please, if you have not yet subscribed to this YouTube channel, please do well to press the subscription button and the notification button in order to see all of our subsequent videos online. Please also remember to share this link and this video with your friends, colleagues and relatives, so also they can be also beneficiaries of this YouTube channel. Thanks for watching us once again. God bless you. We wish you all success in every of your academic and behavioral in life in Jesus' name. Amen. Now today we'll be considering physics practical, particularly on the branch of physics known as mechanics. And here we have physics paper 3Y private candidate 2019 questions. Now this is a question, and the question 2 goes thus. We are talking about practicals under mechanics. We have already posted. If you have not yet watched the practical which I posted on electrical aspect of physics practical, please do it to go and look for the videos down amongst the videos that are posted. So in order to know how to answer questions based on electrical. Now under mechanics an aspect of physics where students are being tested under practicals. We have 3 branches of physics practical. We have mechanics, we have the electrical part and the lights part, which I'm going to upload very soon. So today we'll be considering that of mechanics, and also the electrical has been posted, and we will watch out optics, or let me say yes, for the optics. So now let's go into what we have today, which is the practical physics under mechanics. And the question given to us shows a diagram, and this is the diagram. The diagram about illustrate a sonometer box. A sonometer box is a tool that we use to determine the unknown frequency of a turning fork. It is used in sand. It is used in determining It is used in studying sand. The sand obtained from a turning fork, and determine the frequency of that sand. So now a sonometer is a device that produces that produce sand, and in order to determine the frequency of that turning fork, we use sonometer. And a sonometer is just an instrument that is being made up of several instruments. You can see it consists of You can see this is a rectangular box. This is a rectangular box here. Rectangular box. They have a string of a steel wire. Now this is here is a hollow rectangular box. The hollow rectangular box. So we have a steel wire. We have mass here, which is the load. You can call it load. That is being attached to it. To the string, you can call it load. This place a load in kilograms. So these two knife edges. You can call it knife edge, or I'm just trying to label so that you know what this is all about in real practical. So we have this one is, it can be we call it bridges, and we can use knife edge for those bridges. So in real practical, this is made up of a rectangular box, then 2 bridges, which is the knife edge, the load, which is the mass, the masses, our masses. So, and the rectangular box, and also we use meter. Also there will be meter used to measure the length air. We need meter rule. So these are the experiments to set up these are the apparatus to set up this experiment. So apparatus that was used to set this rectangular box, steel wire, load, the knife edges for the 2 bridges, and the rectangular box which we use and the rectangular ruler which we use to measure the length between the 2 bridges. So this is length L between the 2 bridges. So we use meter rule to determine it. But let's go into the question we are given, because this is an alternative to practical, and that's why we have been given the diagram and information about what? About the diagram, what they have obtained, they put it in what? In words for us to make use of it in order to calculate what? The problems thereafter. Now, the diagram above illustrates a sonometer box with its wire fixed at what? P. Now, you can see the point of here. It's made of what? It's made of what? A steel what? A steel wire. That is wire fixed at point P. At point P, it is being fixed at point P, passing through a pulley. Passing through a pulley. Passing through a pulley. This case we use what? This is a pulley. Passing through a pulley. Now, the wire is under tension T. The wire is under tension T. You can see this is one of the pulleys here. That was what? This is one of the pulley. So a pulley, they use what? They tie the wire along the pulley. So now the wire is under a tension what? T, exerted by a mass M, hanging free at the end. Exerted by a mass M, hanging free by what? There's a tension produced here as a result of the mass. Tension is the force in a what? In rope. Now tension is the force in rope or in a string. So there is a mass that was hung on this string, and the tension that passes through this string as a result of this mass as well, and the force that passes through this string as a result of this mass is what we call tension. So tension in a string or in a rope is force in a rope or string is called tension. So the type of force that we have in a string or rope is called what? Tension. So now the wire is under tension because of the mass that was hung on the rope, exerted by mass M, hanging free at the end. There was no attachment here. A paper rider R is placed at the center of the wire, running over two movable ridges Q and what? S. Now a paper rider R is what? Is placed at the center. The paper rider R is placed at the center of the wire, running over two movable bridges Q and S, and adjustable until the paper rider starts vibrating violently. The mass M and the length L of the wire are recorded now. So after the paper rider has been recorded, the mass M and the length L of the wire are recorded. The tension T and the roots T are determined. The procedure is repeated using 5 more different masses. In each case, L is recorded for each. In this case, L is recorded for each M. Figure 2 and Figure 2b. Figure 2a and Figure 2b illustrate the masses Mi and the corresponding length Li, where I equals 1, 2, 3, 4, 5, and 6. Now, we are told that the mass and the length of the wire are recorded, and they are given in Figure 2a and Figure 2b. Now, they have already been given us the M and L that was recorded in the experiment, and this is what we are concerned. We are more concerned of in science practical, the results that were given, they were obtained, and were given in the question. So now this is the result obtained from this experiment, and it is given in form of this for us to maximize in order to answer this question. Now, the first thing now is the question is now asking us that read and record Mi, that is the mass. As you can see, this is a weighing beam, So it consists. This is the region of the weighing beam, and this is the mass of of the object of the earth. This is the mass of the earth load placed in the weighing. This is the mass of object attached to this string, and thus mass of object was weighed on a weighing beam. Now, and the reading is the reading for mass 1, mass 2, mass 3, mass 4, mass 5, mass 6, and the length obtained, the length of the wire obtained is given in in form of this. In a meter rule, on a meter rule, using a scale 1 centimeter represents 0.1 meter. So we are going to now try to what? Put our reading in what? In some what? In format that we are required to do it. Now measure and record what? So read and record MI. Now let's start reading our what? Let's start to read our what? MI. Now what? How do we get our MI? Now solution. Now solution. We have what? Solution. Let me box it here. So we have M1. What's our M1? Now when you look at this one, we are having what? 0 to 5 here, 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30 and 0. So this is 0 mark 0 and mark 0 and mark 30. So now here now, if that multiplication from here to here is 5, Abi, it means this big mark here with blue line is going to be what? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So it means that this big line here is a 1, 0 gram, 1 gram, 2 gram, 3 gram, 4 gram, 5 gram. Now what will the middle number here, the red number represent? What will the red number line represent? If the blue line represents 1, so it means that this 5 line divided by 1. So 1 divided by, from here to here is 1 kilogram. Don't forget, from here to here is 1, from here to here is 1 kilogram. So 1 kilogram divided by 5. 1 kilogram divided by 5. You see that it will give us 0.2 kilogram. It means that each red line here, each red line is 0.2 kilogram. 0.2, 0.4, 0.8, 0.2, 0.4, 0.6, 0.8, 1. So now if one red line represents 0.2 kilogram, it means that this is 1.2 kilogram. So M1 is 1.2. M1 is 1.2 kilogram. Now M2, look at where it is. This is what? 1, 2, 3, 4. Now 4 to this point, blue line now is 4. Now this is 4.2, 4.3, 4.what? 4.4. Look at this. This is what? 4 point what? Sorry, this is 4.2, 4.4, 4.6. Because this red line is 0.2, so this is 4.2, 4.4, 4.6. So this is 4.6 kilogram. Then M what? M3. What is M3? M3. Let's see. What is M3? M3 is how many now? Look at this. M3 is, this is 5, 6, 7. 7.2, 7.4. 7.4 kilogram. 7.4 kilogram. 7.4 kilogram. 7.4 kilogram. Then M4. M4. Now look at this very well. This one we have what? 10, 10.2, 10.3, 10.6. So we have 10.6 kilogram. 10.6 kilogram. Now we have M5. M5 will be equal to what? M5 is 5 here, M5 here, this is M5 here. So we have what? Look at this, we have this is 15, 16, 17, 18, 18.2, 18.2, 18.4, 18.4, 18.6. So we have 18.6 here, we have 18.6. So let's read very well. Is there 18.what? 18.2. Okay, it is on this 18 on the fourth aspect of it, the second one. So you have 18.2, 18.4. You have 18.4 kilogram. 18.4. And the last one is what? M6. M6. M6, this M6 here. So this is just 25, 26, 25, 26, 27, 28, 29. So this is exactly what? This is 29 kilograms. So you have we have already what? Read M1, we are through with what? Reading what? M1, MI rather, we are through with reading the masses given to us. So we have read the word mass given to us. Now measure and record NI. Measure and record what? LI. Now measure and record LI. We have to measure and record LI. Now we are done with what? That we have to what? Record what? LI. Now how do we record LI? How do we record LI? NI is small letter NI. Small letter NI. So now you have to use your meter rule to measure what? You have to use your meter rule or use your what? Whatever in an exam, you have to use what? Your mathematical sense ruler, or you buy a long ruler, that is the 30 centimeter ruler. Take it along to avoid any kind of shortage of resources, because there are some, you want to draw your slope, the small ruler in the mindset might not be long enough to draw your slope. So it's better you provide yourself, or you go along with what? The 30 centimeter ruler. So, or you can also make use of the mathematical set ruler, depending on your or your choice, but it's advisable to take along the 30 centimeter ruler. Now, this one, I'm going to be using this one now. So you measure this one. So it is when you measure it on what? On your question paper, it is between your 0 here to this point, to this LI is 0.7 centimeter. 0.7 centimeter. Now, from this point end here to this L1 is 0.7, to this place is what? 1.4, and this one is 1.4. So L, which is L1 now, our head now, L1 is 0.7 centimeter. When you do that, you also measure L2 from this 0 end here, from this 0 end here. Measure from this 0 end here to this place. We are going to have, when you measure it, ensure that you have no parallel error. Avoid parallel what? Avoid that you have what? You have no what? Doing what? I ensure that what? There is no parallel what? Error. You look at it straight. Not that you look it from side view. You look at, make sure that your readings is on the what? On the meter rule. Straight to the meter rule, so that you won't see or you not experience any form of what? Parallel what? Error. So the next one will be what? When you use your ruler on that question paper, it will be 1.4 centimeter. These are the LI on the what? On the given what? Meter what? Rule. Now remember, use given scale to what? To convert to real length. Use the given scale. What is the scale given to us? This is the scale given to us. This is the scale given to us. Scale is 1 centimeter represents what? 0.1 meter. 1 centimeter represents what? 0.1. So if I want to convert this one now, I will say that since the scale given to me is what? 1 centimeter represents what? 1 centimeter equal to 0.1 meter. 0.00 meter into decimal 3 decimal place. They give me 1 centimeter to what? 0.100 meter. Now it means that my 0. For my head 1, I will be 0.7. For my head 1, for head 1, 0.100, so 0.07 meter. 0.7 times 0.100 is equal to 0.07 meter. So it means that my head capital letter 1, which is what? Capital letter N1 equal to what? is 0.07 meter when I convert it to what? When I convert it to using what the scale. So the real meter here we got for the L1 is equal to 0.07 meter. Now we now say we should do that for all of the Li. Then we tabulate our results of values. Table of values. So you have table of values. So you have to, the first column here is we have the serial number. The serial number 1, 2, 3, 4, 5, and then what? 6. So the first entry we are asked to do is what? The MI. The next one we are asked to do is the LI, small letter LI. So now, which is what? This one is in kilogram. Remember to include your units. Kilogram, this is in centimeter. The LI is in centimeter. So now, the next one is what? The next one is the L after yours, the capital letter L-I. The capital letter L-I in centimeter, which is equal to what? That is 0.100 multiplied by small letter I. So we have what? Our meter. So whatever we get here, you multiply by 0.100 and it will be in meter. So that's another column. Now, based on what we did here. So now, next thing that we are asked to do now is to look for your what? Evaluate what? Tension. And note that the tension is equal to what? Mass times what? Mass times acceleration due to gravity. Acceleration, and in the question you have been given what? Mass acceleration to be 10 meter what? Per second square. Now, tension is obtained by the formula mass times what? Acceleration due to gravity. And the mass of the acceleration due to gravity has been given to you, which is what? 10 meter per second square. So therefore, our tension here will just be equal to 10 times mi. That's the acceleration due to gravity times mi that we obtain here. Then we are asked to calculate the root what? The root t. That is square root of what? The tension. Square root of the tension. So that's how you prepare your table of values when you are in exam hall. So remember that the unit of what? Of tension is what? Is Newton. The unit of tension is Newton. Newton is measured in what? Tension is measured in Newton because it's a force. So let's now import our value. This is 1.2, 4.6, 7.4, 10.6, and what? And 18.4. The last one is what? 29 kilogram. So the Li, here we have 0.7. Let's put it to 2 decimal place. Because of 2 decimal place, you can decide to put it to 2 decimal place. I'm adding zeros to this one also. This 2 decimal place. This one is 0.8. Okay, the next one is 1.8. 1.40. The next one is 1.70. The next one is 2.10. Next one is 2.80. And the last one is what? 3.50. So the Li now, multiplied by 0.1, so it moves 0.000. So because it is 0.1, let's leave it to decimal place because they put this one to this decimal place, 3 decimal place. So this is the answer here also has 3 decimal place. So and multiply this by 1.40 times 0.1, we are going to have what? 0.140. So you move by 1 time. So we have what? 0.170, 0.210, 0.280, and 0.3350. So that's that about that. So now the tension is equal to mass times acceleration is equal to gravity, that is 10 times mi. So we multiply this 1.2 times what? 10, which is what? 12 Newton. This one will give you 46 Newton. This one will give you 74 Newton. This one will give you what? 106 Newton. This one will give you 184 Newton. This one will give you what? Sorry, this one should be 99.00 into what? 3 decimal places. So this one will be 2290 Newton. So now, after doing this, after done that, done this. Now we have to find the what? The root of t. That's the square root of what? Of the tension. Square root of the tension. And to find the square root of the tension, you need to press your calculator. Square root of what? Of 12 will be what? Will be 3.46. The square root of 46 will be 6.78. The square root of 74 will be 8.860. Now the square root of this one is about 10.29. 10.29. When you press calculator, when you press your calculator, 184 will give what? Root of 184 will give 13.56, and the root of 290 will give around 17.02. So this is how to prepare your table of values for the experiment. So we have the serial number here. You have the serial number SN. You have the serial number SN. You have the mass MI. So the mass MI, you have the LI centimeter. You have the capital letter L, and you have the tension T equal to mg times 10 times mi. I have the square root of what? Of t. Square root of t. So which is what? So it's the square root of t. That's the unit. So remember to put all of your units inside what? In place. Inside what? On the table. So now let's move to the next question. The next question I say we should what? We should use the given scale to, after done that, evaluate to have done this. In this case, using what? Take what? Evaluate square root of t. In each case, take what? G. You have already done that. Now, the next question is what? I've tabulated already. Say, F now say, plot a graph with root what? T on the vertical axis and L on the horizontal axis. Determine the slope of the graph. Now we have to plot the graph of what? Of square root t against what? L. So we have to draw a graph of what? Graph of square root what? T against L. So this is the title of our graph. So we have to do this. We have to plot the graph of square root of what? Of t, which is the tension, square root of the tension against what? Against the length. Against the length of the what? Of the wire. So the tension, the square root of the tension in the wire against the what? The length of the what? Of the wire. So we have to four of us write the table of our values out. So we have on the x-axis there, we are going to be having our, this one will be on our value. This is vertical. They told us this is vertical axis. Our vertical axis, and this one is what? It's on the horizontal what? Horizontal axis. So now that is our L will be on the x-axis. Our L will be on the x-axis, and our T will be on the what? The square root of t. Our square root of t will be on the what? Y-axis. Please note this. So it will be on the y-axis. It will be on the y-axis. So the value of our what? L now is L is meter, because I've converted it what to meter. This will be what is 0. What? The first entry here is what? 0.7. So let's put it to 2 decimal place. So this one is 0.14. This one is 0.17, 0.21, 0.28, and the last one is what? 0.35. So a meter. Then the square root of t to look at this already in 2 decimal place, but the highest value here that we have here, is what? 17 point what? So 17.02 is better. We approximate our value to 1 decimal what place, so that we can use what? 1 decimal place, because the highest value here is 17.02, and to plot it on the graph, we need to what? To approximate to 1 decimal place in order to have all of our values on the what? On the graph. So we have what? For here now, it will not go. We have 3.46 here. Approximately now it will be 3.5. This one will be approximately to go 3.5 on the graph. This one will be 6.8. This one will be what? 8.6. This one will be 10.3. This one will be 13.6. This one will be what? 17.0. So this one will be what? 3.5. The next one will be what? 6.8. Approximately to what? 1 decimal place. So now for the what? For the graph. So this one will be 8.6 as well. This one will be 10.30. That is 10.3. This one will be what? 13.6. And last one will be 7.0. So as to be able to choose a scale for our graph, we need to approximate what? The value. Now we have now the types of the graph of square root of tension, which is in what? In Newton. So against what? Against L, which is what? In meter. So that is that. Now this next thing is to choose our scale. Now the highest what? The highest value that we're having on the horizontal axis here is 0.35. 0.35. Now we are going to consider what kind of scale should I use. Guys, what kind of what units will I use? Now it's advisable for you to, since we are having 0.35, so we are going to use what? 0.05. 0.7, because how many lines am I having here? 1, 2, 3, 4, 5, 1, 2. How many 2 centimeter box am I having here? From here to here is 2 centimeter. From here to here is 2 centimeter. What I mean here is there. From here to here is 2 centimeter. So how many 2 centimeter box do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like 10. Like 10, I have 10. So if I multiply what? Is 0.05 times 10, that will be what? Is 0.5. And my highest what? Value is 0.35. So if I use 2 centimeter represents 0.05, it means that I will have the highest value that I have on this graph along the horizontal axis will be what? Is 0.5, which tallies with what? So I would rather use what? I would rather use that scale that 2 centimeter represents what? 2 centimeter represents 0.05 on x axis. On x axis. Now, what about the y axis now? So 2 centimeter represents what? 0.05. Now the unit of L axis is what? Meter. On L axis. So the next thing now is to what? Is to choose scale for this. Now the scale here, the highest value here is 17. If I use 2 centimeter represent units, will I be able to get to 17? Now if I start, because I'm going to be having what? Leaving space a little bit. If I start from here, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 will give me 16. Times what? I'm having up to what? Like 10 2 centimeter boxes here. So which means that if I multiply 2 centimeter by, if I multiply 10 boxes by 2, if I choose 2 centimeter represent or 2 units, so I'm going to have 20, and my highest value here is what? Is 17. So meaning that 2 centimeter represents what? 2 units. We work for the what? For the y-axis. So 2 centimeter represents what? 2 Newton on the tension axis. Because so now we can now plot our what? Our graph. So now let's try and plot our graph by drawing the what? The vertical axis. The vertical axis. Let's draw the vertical axis. So now I'm drawing my what? The bits here. So let me drop this thing a little bit so that you can see what I'm doing here. So we're having so I have my 0 here, 0, 0. Now this is my T, which is Newton. So it's in Newton now. This is my L, which is in meter. Now I want to, since I use 2 centimeter represent to you, this one is 2.0, 4.0, 6.0, 8.0, 10.0, 10.12, 10.2. Now 10.4. Sorry, this is, sorry for that. This is supposed to be 10.0, 12. So this is 10.0, this is 8.0, 10.0, 12.0, 14.0, 16.0, 18.0. Now again, is 2.0, 4.0, 6.0, 8.0, 10.0, 12.0, 14.0, 16.0, 18.0. So now that is that for the y-axis, that is the t-axis. Now for the L now, we use 2 centimeter represent 0.5, 0.05. So we have 0.05, 0.10, 0.15, 0.20, 0.25, 0.30. Let me clean this. Okay. We have what? 0.35. Then we have 0.40. So let me put my hand back here. So that is L into bracket what? Meter. So 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, 0.35, 0.40. Now we have successfully what? Labeled the vertical and the what? And the horizontal axis. So this is Newton. Now let's start plotting our graph. Let's start locating our graph. 0.07 against 3.5. 0.07 against 3.5 will be what? 0.07. This is what? 0.05. This is 0.05. Now this is 0.05. This is 0.06. This is 0.07. 0.05. This is 0.05. 0.06. 0.07. So you locate it up now. Against what? 3.5. Now this is 2.0. This is the middle one is 3. And each box here represents 0.2. So we have this is what? This is our 0.74 along this side. So around this side, it's first along this side. So now let's now look for what? For 3.5. Now this is what? If this is 2.0, if this is 2.0, 2.0 divided by what? 2.0 divided by 10, we are going to have what? 0.2. Meaning that each small box is 0.2. So 0.2, 2.4, 2.6, 2.8. This is 3. Now 3.2, 3.4, 3.5 will fall in the middle of this. So in the middle of this, so in the middle of this box. So you trace this one down here. But trace it, look at it very carefully. From this box now to this place, we have what? Our point. So we have our point there. So that's that about that. So this is 2.2, 3.2, 3.4, 3.6, this 3.5, 4 here. Against what? Against 0.7. 0.7 is around this place. 0.7 is around. You have to be careful. Very good. 0.6, 0.7 against the 0.what? Against the 0.0 against 3.5. So 3.5 is in the middle of 3.6 and 3.4. So against 0.1. So that is the first point. This is the first point here. I want to press it so I can see it in that place. Now 3.1. That's 3.5 against what? 0.07. Now the next one is 0.14. 0.14. Now look at this. 0.14 is 0.15. 0.14 is this space. This is 0.14. This line is 0.14. This line 0.1. This is 0.14. Now 0.14 against 6.8. 6.8. This is 6. This is 6 here. Now 6.2, 6.4, 6.6, 6.8. 6.8, you trace this 6.8. 6.8 with this word 0.14. 0.14. So where they meet, this one 6.8. This 6.8. So the location is here. So this is the first one. This is the first one. This is the second one. So now the next one is what? 0.17, 0.16, 0.1 7 is along this line. So just put so you can see anything around it. So 0.17 is 0.17. Now 0.17 against 8.6. 8.6. Now this 8, this 8, 8.2, 8.4, 8.6. So 8.6 will be around this place. 8.6 will be around this place. So you clean this. So 8.6. So you can see 8.6 against what? 0.17. Now 0.21. 0.21 is this place. 0.21 is here. 0.21. 0.21. Just put it and so that you can remember. Now 0.21 against 10.3. That is 10.2. 10.2. This is 10.4. So 10.3 falls in between here. 10.3 falls in between here. So we have what? 10.3 here. So that's your point 0.21 against 10.3. Now 0.28, this is 0.3 now, this is 0.26, 0.27, 0.28. 0.28 falls here, 0.28 falls along this line. So you just go like that, 0.28. Just mark 1 point here, so that's not falling. 0.28 along that. So 0.28 against 13.6. 0.28 against 13.6. This is 13. 13.2, 13.3, 13.2, 13.4, 13.6, 13 point what? 6, 13 point what? 6, 13.6. This is 13.6. So we have what? We have our location here. So 13.6. Then the last one is 0.35. 0.35 against 17. 0.35 against what? 17. 0.35 against what? 17. Now, this 0.35 against 17. Our 17 is here. 17 is here. Then against 3.5. So, the location lies here. So 0.35 against what? So here is our what? Our value. So we have to draw the slope. So let's first draw the straight line graph. The straight line graph. Let's see if we can take 1, 2, 3, 4. Here we can take 4 points. Let's consider taking 4 points. So if we have something like this now. So these 4 points. Remember this such a way that we have one on the top, one on the down. Just take it such a way that we have one. And then no. Okay. Let me just try and take this for the convenience. Let me take this. So I'm having let's now draw our slope. Let's take our slope now. Let's take our slope. Now I'm taking this point here, and I'm taking this what? This point for convenience. So taking these 2 points. Again, this back. Now that's that for our slope. Now let's try and determine the slope x. So determine the slope x, trace this one down. Trace this one down here. And the slope s, trace this one down. Trace also this. And trace this one along the horizontal. Okay. So the last one here is also this one, the vertical axis. So now let's try and calculate our slope. So we can draw two. These are right angle here. So now to calculate the slope now, this is your y1, your y2, your x1 and your what? X2. So now we don't even call it y1, we have already called it what? Don't call it x1, x2, so we can call it what? T1. This is your what? T2. Because we are using tension now. T2, and this root T2 minus what? Root T1 minus what? Okay, we have on this place we have what? L2 and what? L1. So what do I mean by that? Choose your what? This is your point. Root T2, root T1, L1 and what? L2. So our slope S now. Our slope S, that is change in x, our slope x. Our slope x is equal to what? Slope. Our slope x is equal to change in root what? T over change in what? In L. So we have what? X is equal to what? Root T1, T2 minus root what? T1 all over what? L2 minus what? L1. So what's our root what? T2? That is 14. 14.0 minus what? 14.0 minus 4.0. 4.0 bracket Newton all over L2 0.35 minus, and this one is what? This one is 0.06, 0.07, 0.0 what? 0.08, 0.085, 0.085, 0.085 meter, 0.085 meter. I'm going to write it again. 0.05 meter. So now, don't forget that place has meter. So 0.085 what? Meter. Let me even write it again for you to see very carefully. 0.085 meter. So very essential. You write your what? Your unit very clearly, so that people might see it. So this is what? 4.0 minus 14.0 minus 4.0 all over 0.35 minus 0.085. So this is 0.085. This is 0.9. So we now 0.09. We will get 0.10. Now, if you press this on calculator, what do you have? N is equal to 10.0 all over 0.0. It's okay. Minus 0.35 minus 0.265. Don't forget this is Newton. This is what? Meter. So the final answer here is what? 10.0 divided by 0.265. When you press it on your calculator, you are going to have 37.735 Newton per meter. Newton per meter. Please write this Newton very well. Newton per meter. N divided by N. So this is X equal to what? 3.74 Newton per meter. So this is your slope. 37.74 Newton per what? Per meter. As far as this graph is concerned, graph of square root of t against L. So graph of square root of what? Tension against what? Against what? Length. So now let's go to the what? To the questions given and so as follows. Don't forget that the slope here is what? Write it out because we are going to need it. So we are going to be what? Using it for subsequent calculation. So the slope here is 37.735. Now we are asked to state what? State 2 precautions you will take if you are to experiment in the laboratory. Number one is that you avoid error due to parallax when taking your reading on meter rule. Especially when you are taking reading on your meter rule, I will ensure and make sure it is present in your diffusion test. I will ensure that the error due to parallax is avoided. I will ensure that error due to parallax is what is avoided. That's number one. Number two is that I will ensure that the mass is tightly held by what? By the string. I will ensure that the masses of the weight or of the load given to me is tightly fixed to the string. Question says from the graph determine the value of F if LF are related by this. Now, if from the graph determine the value of F if LFT are related by this what? Equation that determine if LF are related by root T FL 1.5. Explain the term resonance. Now we have to calculate what? Determine F. If square root of T is equal to FL over 1.5, if they have the relationship of this. Now, it means that we are going to use this graph to solve this problem. Now, the first thing is to what? Try to get the slope from this relation by multiplying by what? Multiply both sides by what? By L. So when you multiply both sides by L, what do we have? Root T by what? By 1 over L. Multiply both sides by what? 1 over what? L. So 1 over root L times 1 over L equal to what? Root T. Root T equal to what? Sorry. Root T times 1 over L FL all over 1.5 times 1 all over what? L. So this one cancels out. So we have what? Root T all over L equal to F all over 1.5. So 1.5. Now from here now, you can easily cross multiply and get out, or you can easily what? Multiply as well by what? By 1.5 again. You can multiply from here to 1.5. So 1.5 times 1.5. So this one comes as so like this. So your F is given as what? 1.5 root what? T all over what? L. And therefore F now root T over L is same as our slope. So it means as S multiplied by it means that 1.5 multiplied by what? Our slope S. Our slope S, so which is equal to 1.5. Now our slope is root what? Changing root what? T all over changing here. Don't forget about that. So that's why we're substituting S. So 1.5 times what? 37.7 what? That's 7.35. We are going to have 56.6025. So Newton per meter.